Friends and viewers, welcome to Kns Biochemistry. In this video session, we are going to learn about a very important instrument called pH meter. So pH meter is a very important instrument used for the measurement of pH of a given solution. So what is this pH? pH is a very important parameter or phenomenon, and that is going to help a lot to find out the hydrogen ion concentration of a solution. So by definition, what is pH? pH is nothing but negative logarithm of H plus ion concentration, that to molar concentration of hydrogen ion, that is expressed in logarithmic value. So this is called pH. Negative log H plus ion concentration. So this pH of a solution is basically decided by the amount or the quantity or the concentration of H plus ion, that is proton, present in a given solution. So for that purpose, there is pH scale which is available to find out the acidity or alkalinity of a solution. It is based on that pH scale. So pH scale is a numerical value where the concentration of proton is converted into numerical value, that is called pH value. So the pH value starts from 0 and goes up to 14. So 0 to 14 is pH values. So in between at the center we have pH 7. So that is the central point where the pH of a solution will be neutral. So below pH 7 up to 0 it is called acidic pH. Above 7 up to 14 it is called alkaline pH. So based on that only we are identifying the pH of a solution. At the same time, we have an instrument called pH meter, the latest one, that is going to give the accurate amount of H plus ion present in a solution. So for that purpose this pH meter is used. So this pH meter is having a basic principle, and based on that principle is only it is functioning. So here in this session we are going to learn about the basic principle, the operation steps, and the important applications of the pH meter. So let us start the session. Come and join with me.
Following reactions takes place in the electrodes. The glass electrode, what is going to happen? The glass electrode contains silver, silver chloride and hydrochloric acid. All these remain in the ionized state. Silver becomes Ag plus and electron minus. AgCl becomes AgCl plus Cl minus. HCl, H plus Cl minus. So all the above three, that is Ag plus, H plus and Cl minus, all the three equilibrium reactions are balanced. So in the glass electrode, H plus ion concentration is generated. So the thermal electrode contains mercury and Hg, Hg2Cl2 and KCl. Here also the following series of ionization takes place in this thermal electrode. Hg, Hg2Cl2, KCl. Then Hg is ionized and Hg plus to electron minus. Similarly, 2Hg plus 2Cl minus. Potassium chloride becomes K plus and Cl minus. So the above equilibrium reactions are balanced. So in the thermal electrode, H plus ion concentration is not generated. Then the probe, the types of probes which is present in that pH meter, you have a glass electrode and a reference electrode, then third one combination electrode. So first figure is glass, highly sensitive proton. This platinum ion. This is actually a glass. There is a glass tube. Then this is pH meter, and this pH meter, see that it is having platinum ion. Then here you are having potassium chloride solution here at the center, and mercury is here, calamite is here. Then KCl crystals are deposited there. Porous regions are there. Your refill can be done opening this. Then it goes to pH meter. This is the combined cell, combination cell. That is both the columnar electrode and glass electrodes are combined. So wires to pH meter, it goes there. Two electrodes are inside that. This is gel, which is a silver chloride reference electrode. And reference internal solution is here. This is N11. This is the junction. Then silver chloride covered silver wire is here. Another electrode. Glass electrode, internal solution enters inside this.
pH is a measure of the concentration of hydrogen ions in a fluid. The most common method for online pH measurement is potentiometric glass pH sensors. These sensors work by producing an electrical voltage that is proportional to the hydrogen ion concentration in the fluid. pH sensors have two primary components, a pH-sensitive electrode and a reference electrode. Both electrodes consist of a metal wire suspended in a stable neutral electrolyte solution. The reference electrode maintains a steady reference voltage and completes the electrical circuit with the pH-sensitive electrode by allowing a small amount of ions to flow from the reference electrolyte solution into the process fluid through a small porous opening called a reference junction. The pH-sensitive electrode has a small bulb at its tip that is made of pH-sensitive glass. The electrical voltage across this bulb changes in response to the hydrogen ion concentration of the process fluid around it. If the hydrogen ion concentration is higher on the outside of the glass bulb than on the inside, a positive voltage occurs, indicating the process is acidic. If the hydrogen ion concentration is lower on the outside of the glass than on the inside, a negative voltage occurs, indicating the process is basic. If the hydrogen ion concentration is the same on each side of the glass electrode, the voltage is 0, indicating the process is at a neutral pH of 7. The pH of the process fluid is calculated from the voltage difference between the pH-sensitive electrode and the reference electrode.
Calibration of the pH. So in pH meter, calibration should be performed with at least two standard buffer solutions that span the range of pH values to be measured. So for general purposes, buffers are at pH 4 and pH 10. Both are acceptable for this kind of calibration. So the pH meter has one control that is calibrated to set the meter reading equal to the value of the first standard buffer, and a second control, that is slope one, which is used to adjust the meter reading to the value of the second buffer. So the third control, it allows the temperatures to be set. Construction of the pH meter. So your pH meter, which is having a power pack, that is power pack this side, electrodes or probes that side, and there is inside the power pack you have on-off switch, indicating meter, temperature compensation knob, calibration knob, wire with plug in. And in electrodes or probes, you have glass electrode, columnar electrode, or combined electrode, combination of these two, glass and columnar. The measurement of pH, how to measure pH using a pH meter. The zero of the dial is set mechanically. First you have to set 0 in the monitor. So the knob for temperature compensation, there is a knob for temperature compensation. So that knob for temperature compensation is fixed for temperature of the solution. Then the electrodes are dipped into a standard buffer of known pH. Then adjustment it can be done so that the dial reads the value of the buffer solution. Then the electrodes are removed and washed well with the distilled water. Then the electrodes are dipped into the same solution, sample solution. So the dial shows the pH value of the sample. it's a types of pH meter. So this is a manual pH meter. Manual pH meter, digital pH meter. Two types of it. This is manual one, a manual pH meter. You have electrode stand here, set 0 is done here manually, set buffer is here, temperature compensation of selector is here, then selector is here, electrode is here, then indicating meter is here. This indicating meter is monitor. And next one is a digital pH meter. The values are coming here digital pH meter. Disorders in human blood and human body. Agriculture. In agriculture, pH meter is used. Then drawing it is used. Then brewing in fermentation industries, pH meter is used. Corrosion prevention, that pH meter is used. Dyeing industries, jam and jelly manufacturing, printing, and pharmaceutical industries. All these places, pH meter is used. There is main application.
My dear friends, let's go for a small quiz now. First one, what does a pH meter measure? Temperature or acidity or alkalinity of a solution or electrical conductivity or concentration of dissolved oxygen? The answer is acidity or alkalinity of a solution. The next quiz is this one. Which part of the pH meter is directly involved in measuring the pH of a solution? The power supply or the display screen or the electrode or the calibration knob? Give your answer now. What is the typical range of pH that a pH meter can measure? 0 to 7 or 0 to 10 or 0 to 14 or 0.1 to 15? What's your answer? Yes, you are correct. The answer is 0 to 14. The next one. Before using a pH meter, it is very important to calibrate it using solutions of known pH values. What are these solutions commonly called? Buffers or standards or reagents or indicators? Find out the answer now. Of course, you are correct. The answer is buffers. Which of the following factors that can affect the accuracy of a pH meter reading? Temperature of the solution or condition of the electrode or proper calibration or all of the above? Give your answer. Very good, friends. The answer is correct. All of the above only.